What is web scraping? Web scraping is the process of gathering the information from public domain. All right, like suppose you will be gathering information, whether it is text, whether it is images, or anything else. You will be gathering that from websites, different websites. Now, how it's gonna help us? Suppose I'm just giving you a very simple example. Suppose you are doing it like this, that you are doing a image classification project, okay, and there you need to classify between different between different categories of animals, okay, there are cows, there are cats, dogs, and many other animals, and you have to just classify that which animal is what. You have to just make a model on that. So for that, you just one thing can be that you just go to a Kaggle you just go to a Kaggle website and just type the animal dataset, you will get there. But a more authentic type of thing would be if you just scrape the dataset. So just open any, like suppose any website where different where photos of different animals are there, like different kinds of animals. Just scrap that data. So we will first learn how to scrap that data. Okay, so scrapping of a data is done by many methods. Like there are many technologies for that. In Python, we can do it using the Beautiful Soup library. So Beautiful Soup library helps us to do image scraping inside the Jupyter notebook itself. Okay, so first we will learn about that. So Beautiful Soup library is written as like BS4. Okay, beautiful. Actually, it's Beautiful Soup 4, but it's commonly also called as Beautiful Soup library. So BS4, from BS4 import star. That is from BS4 I am importing all the sub packages and all the things. Okay, then I will just import a library called import requests as RQ, and I will finally import OS. So OS is a operating model system, and that helps us in like maintaining a directory like structure. That is, we can just make a directory, we can create different files under that directory, and we can also append that directories. Like we can just put different files into it. Okay, so if you just want to store anything, like if your model or if your script is just obtaining something, then it's very useful to use OS and get a folder where you just want to keep your data. Okay, so in the next step, what we do is I imported the time library here. Okay, just wait a minute. Okay, so I imported my time library here, and I have a website which is known as http books2scrape.com. Like it's a beginner kind of website for like it consists of the pictures of many books. Okay, like it's and this particular website has been especially tailor made for this scraping purpose. Like if you're just beginner and want to try your hands on scraping, you just scrape this data from the website. Like it's a very simple kind of website containing of only CSS, HTML, and JavaScript. Very simple kind of website, and hence it just helps us in doing the scraping much more faster. So that's why for a beginner we use this. So what I do is I have my request library imported initially. Now I will write it as R2 equal to request, that is rq.get http /books.toscrape.com. That is the name of the that is the name of the like domain, website. Okay, then slash and we will put it within double quotes, like that's usual. So so you must remember that there are different aspects to scraping now. Now we are just going into the deep of this scraping thing. So first, you have to get a like a uh, initially you have to get a like request kind of structure. Like it will, like from the website it will just return a request, and using that request, like it will be a sort of text. Okay, like if you just print out R2, it will be a sort of text, and within that text like a lot of things would be written. You just not get to understand it. and then we have to just parse it in a like using a HTML kind of tree structure. Okay, we just have to parse it using the HTML kind of tree structure. So I did that thing basically. Okay, so let me see if I can just run it in front of you, because it's my Jupyter notebook and I guess it will not take much time, because when I did this thing, it did not took much time. Okay, let me continue with the explanation. Till then, it's all importing like this. And if this all happens here, I'll just show it to you. Okay. Um okay, so we have our time very short. So try to understand each and every, like try to listen everything very carefully. So next thing is now we got the art2, right? Now next come to the next step. So in the soup2 structure, so soup2 equals to beautiful soup in bracket r2.text HTML parser. So I told you that R2 is a request that we get from a website, and we send that using our request library. So we get a request text and we will just parse it within a HTML tree like structure. All right, let me see that. Yeah, it's just imported. Now let me just run this step. Okay, it will just take some time if you just want to see this thing. Now soup2 is already done. Now I'm just printing it. Okay, print soup2.prettify. Now soup2.prettify means that it will this is a very useful thing actually. Like even if you print the soup2, it will be a very disorganized structure of HTML. Like different like in HTML, what is there? That's first there is a body. Okay, like in the inner code there is a body, and above that there are heads, and there are many other things, like there are attributes, many different things are there. So they will all appear in a side by side manner, and it would be very difficult for you to distinguish the tags. Okay, just a minute guys. Okay, sorry for the interruption. So it would be very difficult if you just print it normally, print the soup2 normally. So we add another functionality called soup2.prettify. What it does is it like up to some extent it makes the content somehow understandable. So let's print this to see how it's getting.
Excuse me, sir.
Yes.
Sir, sorry for interruption, sir. Could you please explain SOAP2 again? What is this function HTML dot parser text we are printing? Is
You're
this
parsing the HTML tree structure, that's it. You're just
okay?
parsing the HTML tree structure. You get a HTML text, you're just parsing that tree structure. I hope
Okay,
you know
got it.
what's parsing.
Yeah, yes, I got it.
Okay. So when you just print out this soup2.prettify, so in this soup2.prettify, just see here, it's kind of coming in a like formatted structure, like everything is coming a bit organized. Okay, just see this kind of thing, that first here, like these are just some, I guess, some protocols that they are just given here. Okay, and then this link, these are the link href, and here comes the head, and after that the body starts, and the body, there is a header. Okay, so like this everything is clearly written here. Okay, so whenever there is a tag, so a tag within that it is also given very clearly, so that you can just understand whatever it is. Now if I just remove this soup2.prettify, okay, just see here, everything that you have, like it's also like very like almost everything is same, but somewhere or the other you will find that, just see here that here a tag just ends, and just below that only like li tags ends. So not the proper indentation that I wanted is happening. Okay, so if I want, like, it's just a prettifying tool, so don't worry about that very much. I guess better if you just use it. Okay. So for that reason, like, it's a generally it's a very big text, and for that reason I just commented it initially. All right, so now in my soup 2, now as I told that my aim is to scrape images. Okay, so scrap images. Now I, like, in this particular notebook I will only find images. If your aim was to find text, then you would have written some different code. Just see here, images equal to soup2 dot find underscore all in single quote, that is img. That is, you have in soup2, wherever there is an image tag, you have to just like find that thing. Okay, now if it was a text, you would have written in underscore txt. So that's how it happens. Find all means in the entire soup, how many times the image is there, just find the entire thing. Like, give me all the that image tags. So what I did is so here we have the image. Then I took just example called, like, it will be a array type of structure, uh, array or a list. Well, I'm not sure about it. So example equal to images 0. That example I just print out the first element, and it looks like somewhat like this: img alt, that's a alt text, equal to, in bracket, a light in the attic, class equals to thumbnail, src equal to this. And what it will look like is, suppose it will have a, okay, let me see if I just can open this website. Let me see. Cool. So here we have this like this image, particular image, like there's a cover of a book or something, and this name is light in the attic. So I will just right click and I will just go to the inspect section. Okay, so what happened? Yeah, just getting it. Okay, so in the image section, I right clicked and I clicked on the inspect section. So it's just coming to that particular point where the, like, in the code, like the coder who has designed this web page. So that particular code which is responsible for showing this uh, like this particular thing. Okay, so as you can like, as I move or hover my cursor over here, just see in the left hand side that particular thing gets highlighted. All right, so just make one thing sure that you have noticed this thing. Just wait a minute. Just wait a minute. Okay, so let me again click on the inspect.
So can you expand this HTML code tab so like we can see it properly?
Okay, so how can I explain, like, do you have any shortcuts? Like, I haven't personally seen any expanded this thing. It always appears as
If,
like this.
yeah, no, actually, yeah, there must be some this because on my PC I can see it on a big screen. I actually don't know how to do it, but I can see it on a big screen on my PC.
Drag it.
Okay, just dragging
Just you
it.
can drag it from the below part.
Uh, I don't think dragging it will just happen, because, like, as you can see, no dragging, like, that particular cursor doesn't appear. Like, see this particular thing, like, the only thing that I wanted to see, that can you see this src thing? Like, this particular thing will be again shown in my code. What I was trying to tell, that,
Yes, sir, we can see it.
yeah, just see this src thing, because this is an important thing that I will show, like, what's is important in the code. I just wanted you all people to notice this src thing. When I just keep in your mind that whenever I'm hovering my cursor over this src thing, my thumbnail gets highlighted. Can you see that? I guess. Yes.
Yes, sir.
Okay, cool. So just coming to here, just coming to my code. So see the same thing, like alt text src this. So this src, within this src, this thing, this media slash cache and this whole thing. So this is responsible for the thumbnail, that picture, and this is exactly what I want. I don't want the alt text. I don't want anything else. I want only that particular picture to be scraped. Okay, so yeah. So then, okay, so this images kind of thing, like I was telling that I'm not sure is array or a list, is neither, because it's a result, like bs4.element.result set, like it's a bs4 element. Okay, like bs4 is a different kind of element itself. So as you can see it here, I printed the type and it's coming like this. So let me run it. Okay, so I have to first run this thing, then I guess I have to run this thing. Yeah, done. So the part that is most important for us is pulling the actual image is src equals to dot dot dot. That is this particular thing, because this is a URL. Well, it's not quite fully an URL, but it's a URL extension. Okay. Now to break down the output a little bit more, we can use the .attrs method to pull out the URL found in src. Now, if you're just not sure that which part you have to basically use it, so there's a thing called .attrs. Like I guess you are just clearly able to see it, but sometimes what happens that this alt text is big and like this thing goes on, like it's a big kind of thing. So for that case, like if you just feel that okay, I will not invest my energy in searching for the src, so you can do this kind of thing, example.attrs. So we'll get this thing clearly. Then example in single quote src, we'll get this thing. Now here is an important step, and you have to understand it very carefully. So I created a blank list, and the name of the list is links. So links equals to within third bracket. So I created a blank list. So for img in images, links dot append http underscore that is the slash books dot double slash books dot toscript.com slash plus img src. What I'm trying to do, just try to understand it. I'm trying to create a link which will direct me to that particular image, like to the particular image that I want. Let's just click in this image, like in this link. Just wait a minute. You can see this image just floats in front of our screen. You can see this image, right?
Yes, sir.
Okay, so you can see this image. So I wanted this particular image to float in front, like access to only this particular image, because this is what I need. I don't need anything else. So I created a custom, like explicitly created a URL like this, which directs us to that particular image. So how I created it, I obtained my source, which was like through the demonstrated process earlier, and I appended with it http colon double slash the entire URL, the first thing, the entire URL plus img. So it will just direct to that thing. Now I just printed the like I just printed the links, nothing much. Now os.mkdir latest underscore books to scrape underscore photos. So I created a directory. Now in this directory is where I will just keep all my photos after scraping. Till now my scraping process is not complete. Let's come to the next process, our final one. For I equals 1, for index comma image underscore link in enumerate links, if I is less than equals to 10, image underscore data equals to request dot get image link dot content. Now there are many images, but I don't want all the images because these are like tutorial notebook that I just wanted. So what I try to do is I only try to gather only 10 images. Okay, I will just take only 10 images, and so that's the reason I just went into this conditional statement that if I is less than equals to 10, image underscore data request dot get image link dot content with open latest underscore books to scrape underscore photos double slash. That is, I'm going inside the directory. I'm just opening the directory plus str index plus one plus dot jpg. Okay, so let's go this step by step. Okay, first let me see that this step executes or not. Links isn't defined. I guess I forgot to just this step. Okay, so scraping is taking a time. Okay, so see what happening is basically what will happen that for index comma img link in enumerate links. Now in links there are like there is basically two aspects. Okay, so in okay first of all just like this a question to you all guys. Do you know what's the difference between for loop and enumerate? Anybody can tell me? No answer till now. Like we are basically nearing to the completion of the course, and it's strange that you all like okay, so whatever. See, for loop for loop and okay, let me see the chat section. Universe has written some this enumerate prints index position and the element. Exactly. So that what happens in enumerate, that along with the exact element, it just keeps a track record of the index. Like suppose it's going like suppose it's going on like this function is similar to a for loop or any other loop in case, but the only thing is that enumerate gives two output. One is the actual image through which we are iterating, another is the index. So basically it gives a kind of dictionary structure. And in dictionary, how it starts, like first there is a 0 colon particular element, 1 colon particular element. So in this case also, my index would start from 0. But I don't want my picks to be labeled as like suppose what can I say, like pick 0, pick 1, pick 2, like this. I don't want my to be labeled. I want my picks to be labeled as pick 1, pick 2, pick 3, like a normal way. So that's the reason I opened it, and I like just added my index by 1 so that the 0 starts from 1 and so on. And forcibly I am I'm just converting, like by explicitly I'm defining its extension to be jpg. Like that's not required in case. Okay, so I guess somebody has access to the screen. Just wait a minute. Just wait a minute, guys. Okay, that's okay now. So in this case, I'm explicitly defining my extension to be JPG. Generally, it's JPG, but like in some case, if it doesn't get a JPG extension, and so it may cause problem. So if I define it explicitly, it will not do any harm to me. Rather, it will make sure that all my files are stored in a JPG format. And WB plus is write binary plus. That will I will write the files in a binary format. Okay. So with open this entire thing as f dot write image data I plus equals to 1. else f dot close break. So after the 10 limit gets crossed, it will just break the loop. So and then my image will get scraped and it will just come to a folder and all the 10 images will get gathered. Anyone is having any doubts in the web scraping part? Can we simply use W instead of? No, you can't, because like WB is, I mean, purpose of WB plus. WB plus is right binary. If you write an image in binary format, it will be, I guess, shorter in size. It will take like shorter memory space and all. Like it will just write fast. Everything will be faster. That's it. Okay, so I'm just moving to the next thing that I just wanted to explain. So I will just now move to a proper model. Let me just make this thing. Yeah. Okay. Okay. So just wait a minute. Yeah. Sure. Okay. So now what I'm just like, this is a model. Like I just created a model on like this on Kaggle. Now you may be like wanting to know that why I didn't do this in my Jupyter notebook, or like in Jupyter notebook especially, because in Jupyter notebook like I have uh, very limited RAM and like this requires 814.4 MB space. Okay, so every time it was getting out of RAM, so that's the reason I use Kaggle kernels. You can use Colab also, no problem in that. So first I imported all my libraries. Just see the libraries: Keras, NumPy, Pandas, zip file, because the file that I have is in zip format. This test1.zip, train.zip is in zip format. So I have to unzip that.
Hello,
So that
sir. Sorry. Hello, sir.
yes,
Sorry for interruption, sir. Is this the same project that you told it earlier? Is this continuing or is this another other one?
I didn't discuss any project earlier in your class.
I mean, the file notebook that you discussed, is this continuing?
Okay, so the previous notebook that you were talking about.
Yeah.
No, continuing means, yeah, the concepts would be continuing, but actually this is a like this particular thing like I was just showing to you. It's on different data set, and that's on different data set.
Okay,
I
okay,
would be
okay, got it.
explaining to you. I would be explaining to you all the concepts that would be required to make a full-fledged project. But like first you have to do like the image scrape, like web scraping, and then you have to just run your like build your model. So that's how you build a project. Okay, but like that thing I was going to discuss in your class, that like like I had a good data set like in the Kaggle, so I told you the technique how to scrape it. Now, if you just want to like build this model using your scrape data, absolutely fine. It will perfectly work on it. Just scrape your data from any like National Geography, HD.com or like this. Scrape all the cats and dogs images and go for it. No problem. The scraping process will be the same. The model building process will be the same. Just the thing is that it's working on different data. Okay. So I imported all my libraries. I imported zip file. I imported matplotlib. I imported OS. I imported Shutile. Shutile is a library which helps us in file dealing. Then in the keras.preprocessing image, I imported image data generator. Okay, can anybody just tell me what this image data generator is used for? If you have just learned CNN, it would be like you would just tell in seconds. And
It will extract the features.
no, for that feature we use convolutions. To resize, no. Well, for resize we have different things. Like You can just reside using OpenCV library only. So why to use Keras? Image data generator is used for data augmentation. No. To get information of image, no. So to get information of the image, if you want some information summary of the image, so that would be very easy. Like why do we need to use Keras? So image data generator is used for data augmentation. Data augmentation means that sometimes if you just want your data to be foolproof, or if you just want your model to be foolproof or much stronger, then what you do is that suppose you have an image of a cat. Okay, you have an image of a cat, but what you do is the same cat image, you just like suppose turn it 90 degrees. Okay, it will be the image of a cat but tilted, but it will still be a cat. So your model needs to detect that thing as cat only. It should not be the case that if a inverted cat image comes, then your model classifies it as a dog. So that things should not happen. So for that we need to train our image on inverted images also, or resized images. So for that reason, we use image data generator, and that is basically the purpose of data augmentation. Save the overhead memory. What do you mean? Okay, so working with files. I have the zip file here, test1zip, train zip. Okay, with zip file, just a minute, with zip file dot capital zip file in bracket this thing comma r means I'm just reading the images as zipref dot extract all in the base directory. So dot slash is the base directory in any case. So just go to the base directory and just store the unzip file there. So I did the same thing with the test one also, and my both the zip files are unzipped. Then print total train images. So I'm just counting how many images I have. Print, I hope you know list comprehension. So print len f for f in os.list dir, in bracket there is a slash dot, like in bracket there is a dot slash train if os.path file. Okay, so this thing tells that if os.path.is file within bracket os.path.join this train comma f, like path.is file tells that whether that particular path exists or not, like whether that particular file path is a valid file path or not. Okay, so if your is valid path, if your the path that you have just entered is a valid path, then it will give a result as 1. If not, then 0. What does os.path.join do? So keep this thing in mind because you will be using it frequently. os.path.join is basically like combines two different paths. The example, suppose you have a image. Okay, so how would the image look like? Suppose cat1.jpg. This would be the name of an image. Suppose cat1.jpg. But if you want to locate the file path of it, you can't just tell that cat1.jpg. You have to mention the full file. So in this case, I have my cat1.jpg inside my train directory, and the train directory is located in my base directory, which is the dot. So dot slash train, within that I'm just adding my cat1.jpg, so that now translates to dot slash train slash cat1.jpg. Okay, so if that particular path file exists, then like if this condition is done, like if this condition basically is giving me a positive result, then len f for f in os.less dir, then within this train, that is, I'll just iterate through each of them. I'll just make sure that condition happens or not, and I'll just keep a count that how many of such instances appear. So that's in a way counting my total number of images in my train directory. All right. So my train directory image, like I did for all of them, train images, test images. Okay, so let's come to this part. Now I want to see that in my train directory, how many cat images I have. Now, one thing which is fortunate with this, like fortunately for you, that in this dataset you have your images labeled as cat1.jpg, cat2.jpg, cat3.jpg like this. But in other cases, you may have what does OS path file do? I just now explained it. Okay, just wait 1 minute. Okay, so I just explained it now that OS. Okay, just a minute. We're talking about it gives positive or negative. Yeah, it gives positive or negative. Okay, so like it just tells that whether that particular file path exists or not. If it exists, it gives +1. If it not, it gives 0. If we scrape images from web, we won't get labels. Yes, if you only scrape your images from, if you only scrape the images from web, you won't get labels. But if you scrape the alt text, you would get the labels also. Okay. And how would you scrape the alt text? The Ruchi Namjoshi. Okay, I'm addressing this to you. So how would you scrape the alt text? When I showed it here, that just let me come to this particular path. That soup2.findAll img. Okay, so in this like in this particular line of code, if you just change this img to txt, you would get the like alt text. And fortunately, if your alt text is somewhat like this cat1, cat2, and like this is a like man-made data set, so I won't guess that your labels would be like that still. And if your labels aren't like if you don't have your labels, okay, so this might be a good case to ponder upon. Just let me see the chat. Alt text may differ for every image. Yeah, I was telling that only. Alt text may not, it will differ for every image. Why would the alt text be same for any image, any two images? It will differ for every image. And now you are doing a supervised learning, right? Here you need to have some labels in your trained data set, like corresponding to every image there should be certain label. Otherwise, how will you train your model and finally give your output on the test part? So for that you need labels. Now, if you don't have anything, you are just building your model from the scratch. Then one thing that you can do is, first you gather all the data, you perform some unsupervised learning on it. Unsupervised learning, I guess you know, like k-means clustering. You apply some clustering algorithm on it, get a high accuracy, just optimize that algorithm again and again, get a high accuracy. Okay, so what will it do? All the images that will look a particular type will be separated, and like all the images which will look like a cat will be separate, will be kept in one cluster, and all the images which will look like a dog will be separated in one cluster. There would be still errors, there would still be errors because no clustering will be like full image free. Do that thing, and after that you just get it, label all the images in your cluster 1 as cat, label all the images in your cluster 2 as dog. Okay, you can do that thing. Next question is, can we get both text and images together? Like if you talk about a particular notebook, the answer is yes. But as literally you can't get it together. You just like if you do something like this, that images equal to find all image img, then and below that if you do text equal to find all text, like that you can get it together. List dir again. I didn't tell list dir till now, so let me explain, then you will ask it. Okay, so in the os.listdir, what I was telling, that os.listdir gives a list of all the elements that are present in a directory. Okay, So let me see that whether I can show it to you or not. So here I just obtained a fresh sale. HTIR. Okay, so within this train directory, all the images that are present will be there. I hope your question is cleared. All right. So train cat images. So I did the same thing, but only I altered the condition that in my file name there should be a string called cat. So if that string cat is present, I will consider that to be my cat image. That's how we counted the cat images. You can see the numbers here. I won't just go into the detail. Note that in the test cat images there is 0 and test dog images there is 0. Why? Because a test dataset should always be unclassified, because that's what you are like that's the dataset you would be experimenting your model onto. So if that would be classified, then what's the use? Okay, so let's come to this part. I equals 0 for dir name underscore file names in os.walk train. That is, it will just iterate through this directory for file name in file names, print os.path.join file name. Okay, so I guess you are getting what this path.join is doing. Now image equal to, like, it will just print this name of this image img equal to plt.imread. So now comes my, now I'm reading my image. I'm just reading my image array. os.path.join dir name file name. Within that, and I'm just creating my entire path and I'm just reading the image. Print.img or shape plt.figure I plt.img show I image. Okay, so I just printed 7 of them, and that comes like this. So this is a dog, there is a, I guess, dog, there is a cat, there is a cat, dog. So they're mixed up. Let's create 3 folders for testing, training, testing, and okay, this should be just wait a minute. This should be training, testing, and we cannot take the test1 folder for testing since the name of the files are numbered there. So your test files will look like somewhat like 2.jpg, 3.jpg, like this. So there's a use of a validation set, right? That you can just what would be the deadline for submitting the project? All this type of questions you can just ask to the to Ashish or like maybe somebody else. I'm not dealing in this matter. Okay, so so here what I'm doing is okay, so where I was like the flow gets distracted like this. Okay, yeah. So in test1 folder, the name of the files would be in numbers like 3.jpg, 4.jpg, like this. Okay. So if we create a validation dataset which is carved out of that train dataset only, so it would work like the train test split. Just think what we did in train test split. We divided our dataset which was labeled originally, and we took one part out and labeled as a train dataset, and we like calculated our model accuracy on that. Like we just obtained our predictions, and with that with the actual target that we compared that and just obtained our accuracy. So we need to have labels to get the accuracy. So for that reason, I'm creating the validation dataset. So train dir equal to os.path.join base underscore dir train underscore dir os.mkdir train underscore dir. Okay, so mkdir means that it will create a directory train underscore dir. So train underscore dir equal to os.path.join. So I just join this path and I will create a directory by this name, train underscore directory. So similar thing I did with val dir, test dir. Okay. Now within the train directory, I created another folder known as train underscore cats. So I did repeated the same process for train underscore cats, train underscore dogs. Within the validation dataset also, I created two folders like this. Within that, even within the test dataset also, we created two folders. I know we won't be able to put anything in it, but finally when we get our predictions, we would be able to put in it. So for that reason, I created the folder. Okay. So our models will be trained on a small amount of data so as not to waste a lot of time and resources copying files to create a DIRs. So what I am doing is my data is huge. Okay, my data is too huge. Now initially what I saw that when I was running my model on my entire data, even in like this is a free version of a Kaggle, even I have a free version of Colab also. So the RAM, it was going out of RAM. Just think of the like there is a 15, I guess 15 GB RAM here. No, 13 GB 13 GB RAM. That 13 GB RAM was going out of memory. So think the amount of RAM that would be required if I use all the images. So well, unfortunately I haven't found out any solution to this cause, and like it's just like I'm also like quite worried that why is it not happening. If you guys just get to any solution of this problem, of this out of RAM problem, I would be grateful if you just DM me, okay, with a solution. Okay, cool. So what I'm doing is I'm just taking some of my images as my training data set. So files equal to cat dot within the second bracket dot jpg format I for I in range 2000. That is, I'm just like simply I'm just taking the first 2000 cat images. So for file name in files src equal to os.path.join, I'm just creating my like I'm just initializing my src variable in to this path. Then I have my dst variable. Okay, somebody asks this file is continued with the previous one in Jupyter Notebook. No. So dst equal to os.path.join traincats.filename, comma file name. So I created my source path. I created my destination library also. Destination is that my file name would go to traincats. Now what I'm doing is shut.il.copy file src, comma dst. So this dot copy file basically helps in copying my file from one location to another. So my destination, so my destination is traincats, comma file name. So what I'm doing is I am just copying my files from my original location where it was to the directories that I had created in my previous cell. So originally my file was in the train folder, and now I have created traincats. So the first 2000 image I will just copy from there to here. From 2000 to 3000 I'll just put it in valcats. Okay, for the validation part. So 2000 images will be for training, 1000 images will be there for validation, and finally from 3000 to 4000, that 3000 to 4000 is a number list. So basically it's 1000 images. I'm putting that in test cats. So I will just test on 1000 image. Fine. Same methodology I applied it for my dogs. Same 2010, 1000, the same calculations. Now in train cats, I'm just printing out my images number, like the number of images I have, 2000 and 2000. Let's come to the data pre-processing part. Now you have, until now you have just worked with files. Until now you just sorted your files out. Okay, this will belong to this file, this will belong to this file. Now you're ready to work. So let us prepare the data for the VGG16 model. Now, if you just aren't aware of, in CNN, there are different kind of architectures. Okay, there are different kind of architectures. Like basically every year there is a competition organized, and in that competition, the best CNN architecture is chosen, and like the person who has built the architecture is given some prizes and all, and so that adds to the architecture list. So for 6 to 7 years this competition has been going on, and as a result there are many architectures available to us. So some of them are AlexNet, then VGG16, VGG19, then DenseNet, which I've used here. I've used only VGG16 and DenseNet here. ResNet is there. Okay, so if you just want to know more about it, like if I just try to discuss that VGG16 and VGG19, I wouldn't be able to finish now. Okay, so I'm just telling you the resource, the best resource that is available here. Another file, keras.io applications. Okay, so this is the official blog page of the Keras. Like all the indentation is written here. So here are all the architectures that have been developed till date, exception VGG16, VGG19, ResNet 50, 101, and all this one. All these things are there. So I use this and DenseNet 1-to-1. Cool. So if you just want any more information on how like VGG16 works and like that, so you are free to go there. So first, before using the model also, we would like to prepare our data. Okay. So data gen equal to image data generator rescale equal to 1 dot by 255. So as I said, data augmentation starts from here. Resizing and rescaling is also a part of the data augmentation, not only rotating. Because suppose if your cat size is, suppose you trained on medium sized cat images and somebody gives you an extra large cat image, so that should not be dog. So that's the reason basically resizing and rescaling is also included in data augmentation. So I'm just defining an instance of this image data generator. Image size equal to 150, 150, batch size 64. I hope you know what is epochs, what is the batch size, because these are things that are that were basic to CNN. And CNN class has been done to you, so I won't discuss that again. Train generator equal to datagen dot flow underscore from underscore directory. Train dir target size equal to image size, batch size equal to batch size, class mode binary. So I would explain what's going on here. Flow from directory means I am just obtaining my images from the directory. That's it. So from the train directory, I'm obtaining the images. How? I'm just editing, like kind of editing the images and obtaining. Like don't take the editing word literally, because what I'm doing is I'm just resizing it and rescaling it, and I'm just editing here. I'm just obtaining it then. So it is a similar thing for train generator and well generator. Same thing. Okay. So yeah. Then for data batch, labels batch in train underscore generator, print data batch shape, labels batch shape. So there you must notice one thing, that when you are just obtaining all the things, class mode is binary, means files are written in binary, so it's obvious that your obtaining mode will also be binary. So data batch and labels batch means two things. Like one, like in your train data set, it was labeled, so in corresponding to each image there is a label. So I'm putting my labels differently, I'm putting my data differently, I'm keeping them separate. Like if you just correlate with your supervised learning, you kept your X and Y different, right? So that's the thing that I'm doing it here. And I'm printing the shape of it 64, 150, 150, 3. 64 means the batch size here is 64. Okay. 150, 150. This image size is 150, 150. And 3 is the color channels. That is, there are 3 color channels. Now this is the VGG16 model, a picture that I got from somewhere in the net. Suppose there is an image. It goes under convolution plus ReLU layers first. Then it will go under a max pooling layer. It will go under again under convolution and ReLU layer, again under max pooling. That is, convolution and max pooling layers will go on alternately. It will go on and go on until the size reduces and reduces, and finally when it reduces to a suitable thing, you will just like you will just obtain here, like you will just put here ReLU function again, and finally after that a softmax function to give the binary results. So I'm now creating a VGG16 like a model basically. So weights equal to ImageNet, include top equals false, input say 150, 150, 3. So these are just basic default parameters. I didn't change anything except then this 150, 150, 3. Okay. Now conv underscore base or summary. So when I created, so even in the case of ANNs and CNN, like the normal ones, you saw that like whenever in the sequential one also we were creating any sequential CNN, we are creating any model, we could easily see the summary of it. That is how many, like how is my model, like how my model is built before just putting on the data into it. Okay, just see here the same thing that I showed in the image, the same thing is being here. Okay, I'll share this thing, so those who will have any doubts will just see from this. Now, okay, so conbase.trainable equals false. Let's come to this part later, like after you understand this, I will just come to here. Now model is equal to model of sequentia, and this I just created this thing, and model dot add conbase model dot layers dot flatten dense, like 2 dense layers after the flatten here. One using the ReLU, another using the sigmoid. So I created my own kind of sequential CNN. Everything, like why I'm creating this, everything you will understand later. And I just printed the summary out here. Model.compile, I'm just defining my optimizer, that is RMS prop, and my loss as binary cross entropy, metrics as accuracy. Okay. Now in the callbacks underscore list. Now keras.callbacks.early stopping. Let's see what this thing is. Keras.callbacks. Learn about this. So these are all Keras APIs, right? So early stopping, these are my basic, like these are my default hyperparameters that will be there in the keras.callbacks.early stopping. So stop training when a monitored metric has stopped improving. Assuming the goal of a training is to minimize the loss, with this the metric to be monitored would be loss and the mode will be min. A model.fed training loop will check at end of each epoch whether the loss is no longer decreasing, considering the min delta and patience if applicable. Once it's found no longer decreasing, model.stop training is marked true and the training parameters. And the training terminates, sorry. So once your model has stopped improving, it will just stop training the model. So I just imported this. Monitor accuracy, patience equal 1. Keras.callbacks.model checkpoint, file path equal to VGG16 standard.h5. That is, I'm referring to my VGG model that I just created there. Monitor equal loss, SBA best only equals true. So this thing basically checkpoints my model. That is, I don't know that how many of you have just used a checkpoint in Jupyter notebook also. Like there is a Option 2 to checkpoint. So checkpoint means at what stage does the trading stops. So the final stage, it will just save it. Okay. So then we will go to the training part, the actual training part. History equals to model.fit train underscore generator. Validation data equal to val generator. Steps per epoch equal to train generator dot n divided like double slash means I don't want any decimals. Batch size. Validation steps equal to I just selected it as val generator. Same thing. Epochs 5. Callbacks equal to callbacks and school list. So here is my epoch thing, and the final accuracy is 0.8740. If you just improve your epochs to 10, it will go on to more accuracy. There's no problem in that. Okay. What do we mean by callback? I just explained it now. Callback means like there is no particular meaning to callback. It's just a particular function. So in the next step, accuracy equals to history dot history accuracy, val accuracy equals to, okay. So just 1 minute, just 1 minute. Okay. Just 1 minute, guys. So now what we'll try to do is I will be plotting a graph. All right, I will be plotting a graph, and that graph will basically depict my accuracy as well as my step loss with each epoch. So for that I need to store the history at each epoch. All right, I have to store the history of the loss as well as the accuracy at each epoch. For that reason, accuracy equal to history dot history accuracy. This is a separate library. Okay, don't worry about that. So in the epochs, I just created all this, that range 1 dot len of accuracy, that how many different accuracies we have. We have 5 different accuracies. So my epochs is also like basically 5 plus 1 means the starting point will be plus 1. So that's the reason, like from 1 to this thing. Okay, so basically it becomes 5. I just plotted this thing. So it will come somewhat like this. There is the training accuracy. The training accuracy goes on increasing like this with the 5 epochs. The validation accuracy also goes on increasing like this. Training loss decreases as the training accuracy increases like this. The testing on the test data. Now we are done with the validation. We will just now do the testing part. So here test underscore generator equal to data gen dot flow from directory, the same thing, that is I am just obtaining my images from the directory, the test directory. Now in previous case I use the train directory, and in this case I'm using the test directory. Class mode binary means since the file is written in binary, I will read it as binary only. Batch size is batch size, target size is image size, that is 150, shuffle false. Found 2000 images belonging to the 2 class. 1000 for dogs, 1000 for cats. So that's how 2000 images calculation occurs. So this step is still going on, the process. As you can see, since I had taken only a small portion of that, still my GPU usage is showing full, and it's still now going on. So this is painstakingly slow, so I can do nothing about it. So I'm
So
still
you
not
can try can you try with TPUs on this Google Colab? I think it will work more better.
Okay, with TPUs I can work, but the thing is that I would then again have to run the entire notebook from the beginning.
Okay, sir. Okay, sir. No problem.
Okay, so let me see that this is taking time. Yeah, okay. So fortunately, it just gave me the thing. So what I'm just trying to do, I'll just see my test accuracy and test loss. So as you can see, this model is an entire failure. with a test accuracy of 0.26 and a test loss of 0.89. Absolute failure. All right. Just note which model were we using. Although it worked well on my validation data, still it worked very very badly on my test data. Just wait 1 minute. This model is there. This model is there. Okay. Just wait a minute. Where were we using? Yeah, so we defined a model right here, and this model was our defined model. Like, this is not the VG16, it's the our defined sequential model. Like, we explicitly defined it. No, this is not overfitting. Overfitting is a different concept. If you just carefully notice what I just said, I had two types of models here. One was a VG16 that I created, that I just, like, I didn't create it anything explicitly. It was there, I just imported it. Another is a sequential model which I explicitly defined. So using that explicitly defined model, it's coming very bad accuracy. Okay. So now I will just carry on my data augmentation. We will perform turns, reversals, displacement of pictures. Train data gen image data generator 0.2. Okay, another cause of this very poor accuracy can be because of this data augmentation thing. That in my test part there were some like inverted, tilted images, zoomed images. So that particular images my model wasn't able to detect it. That can also be a case. So let's do the data augmentation first. We haven't done it still now. Okay, so let's just run quite a few number of steps. Till then I just show it to you. So train data gen, image data generator, zoom lens 0.2, horizontal flip true, rotation range 30 with which shift range 0.2, and this all. So now there might be a question in your mind that, okay, so you have done all these things, so how do we know the exact values and how do we know the parameters? Even I don't remember all these parameters. What I did is that I went to the library, I saw what are the hyperparameters in that, I just give explicit values, like जो मेरे को लगा सही है मैं वो दे दिया. ठीक है, तुम लोग कोई और भी वैल्यूज दे सकते हो, कोई दिक्कत नहीं इसका. मॉडल विल ट्रेन ऑन दैट ओनली. Give in rotation range instead of 30, give it 40. The thing will be the same. So I did this thing. Okay, the train generator. Okay, I did the same thing again. I just obtained my data sets, found 4000 images belonging to two classes, found 2000 images belonging to two classes. Then see here, like I'm just printing a image what happens when we do data augmentation. This is the image of a cat. Then the cat is tilted. Then the cat is tilted this side. Like this is left side tilted, this right side tilted. This is just like move to the right words. This is move to the left words. This is a combination of some different steps. So this is how it works. I think this is zoom out function. I will do fine tuning. Okay, so freeze the layers from the fifth last block. It's better to take this block since, okay, you will not understand this. Let's come to this code directly. Now if you just remember, let me just come to that particular part. I have defined my conv base dot trainable equals to false. That is, I have created my VGG16 model, but I had set initially it to be false so that I cannot train anything in it. Like this was a unrelated step, but it would look some more professional. So that's the reason I did it. So I set it to true. So now I'll be using, I think, my VGG16 model. Conv base trainable equals to true. Set trainable equals false. You'll see this later on was this thing. For layer in conv base.layers, if layer.name equal to block 5 underscore con1, set trainable equals to true. If set underscore trainable, layer.trainable true, else layer.trainable false. Okay. So then I'm just compiling my model, same thing, loss, binary cross entropy, and the optimus is RMS prop, the matrix is accuracy, entire thing. So let me just train this model and just run this step. Maybe run a few more steps. Till then, I'm just explaining it to you. Now let's see my VGG16 mod, like summary. See in this part, like this is only a VGG16, only a part of the VGG16. How could I tell that? I again have to scroll up and move to my VGG16 original summary that I had. Maybe, yeah, this part, this particular thing. So this entire architecture, I'm bringing it here. VGG16, which is done, and I'm just training that model. Then again, I did mention the callback list, and then my fitting is going on still now. Okay, so till this epochs, all the 6 epochs get completed, you won't get the actual accuracy, I guess. My GPU usage is full, so I guess I have to just proceed on. So here I am just fitting my model, steps per epoch, validation steps per epoch, epochs, callbacks, so like this. I will just printing the same thing, the same block. Okay, so I don't know what to do now because I don't have the images here. The images will appear same like what it appeared in the previous case, that same type of graphs. All right, so then it will just be test accuracy and test loss, and I guess like just see here, because I had already run this entire model previously, that after additional training and augmentation the accuracy has increased. So whatever the accuracy, the disastrous accuracy that you got in the previous step, so that would be increased. Okay, so that you would see when this particular thing gets run. Now VGG16 is done with. Now I'm doing the DenseNet. Now let's come to the DenseNet architecture. So DenseNet architecture is, okay, I have some chats. Please share both the notebooks or drive on WhatsApp. Okay, sure. So in the DenseNet architecture, what I do is I create small models sequentially, and I just run like they would be identical models, and I just run everything step by step. So BN ReLU convolution. So this is my uh, the uh, the what I should tell, the combination that I will just just wait a minute. This is the combination that I will just use to train, and using this combination I will just carry on with the entire image. Okay, I'll just take the entire image and do it. I will try using DenseNet as I've already worked with it and it showed excellent accuracy. I will also use data augmented dataset and fine tuning without fine tuning on. So first without fine tuning on augmented dataset. So first I created an instance of my this DenseNet 201. So conbase DenseNet 201 where it's equal to image ImageNet include of first a basic default hyperparameter. So I said the same thing. I'm just repeating const trainable false. I'll just do it after the fine tuning part. I'll just set const trainable equal to true and then just move on to that. So it is the same thing here, I guess, same thing. So let me just run it in case this. How do we decide weights? We don't decide weights here. We are just taking the default weights. That's it. So in the model.summary, you will see the weights that were taken. Okay, model summary basically shows how many weights, how many trainable weights, what are the weights, everything would be shown in there. So in the previous case, when I was discussing the VG16 was entirely shown to you guys, the output entire thing was shown. So that thing you saw that everything was available in model.summary, and similarly in this case also it would be available. Okay, so I guess my GPU usage has just gone down. Oh, it hadn't gone down, just it's just happening. So it's quite slow. I I must say. Okay, so this dense net and then the fitting process, I fit it using 10 epochs. So initially, so 5 epochs only, it's taking so much time. I hope it gets completed before your class ends. That's the best thing that I can hope. All right. Then accuracy equal to, then the same thing, I will be plotting this graph. Then in the, like in the, that's the reason I'm just taking here all this like the history of my validation accuracy and the all on the other things that are there. I just took the epochs, how many epochs I just trained for it. I just trained for 5 epochs, so the same thing. Then the accuracy would be printed out here. Now this would be a bit of low, like a bit low accuracy, as you have seen in case of VG 16. Now after fine tuning, now I will do the fine tuning part. Okay. So, okay, so I think I did a mistake just here. So this would be containable. I'll just set it to true. For layer in count base dot layers from 0 to minus 10, there are 10 layers, and I'll just move from the last layer to all the layers. Okay, so I'll just compile it. Then I'll just like so my this so what can I say? My fine tuning has been set on, and after my fine tuning has been set on, I'm just like uh, compiling this in this particular step, and then model does somebody, then the same graph plotting this thing, that same thing appears, and finally the printing the accuracy. So the extra things that I've done is callback thing. That's the main extra thing that I've done, that if you just omit this callback thing, it would be of no harm. But I thought that if I just obtain my callback, then it would be useful in maybe plotting the graphs. So that's the reason I did the callback thing. And obviously, after this fine tuning with the dense net, when we'll get the accuracy, dense net will perform better than VG16. So now you get the accuracy of the validation of the on the test set itself. All right. So basically, your running on the test set has been completed, and after that, just print the labels. How do you write value inside RMS prop? Well, do we write the value inside RMS prop? I don't think so, because RMS prop is a kind of optimizer, and it's just like Atom optimizer. Like Atom optimizer, there's RMS prop. So you can use Atom optimizer also. I use RMS prop. That's the main thing. Nothing else. Okay, 2e to the power minus 5. Okay, so okay, let me ask you a question. So have you so in CNN model or in the NN model, did we use weights? First of all, can you answer me the question? And what was the weights? What was the purpose of the weights that we used there? You can unmute your mic. Yes, the one who was asking the question. Okay, so why did we use the weights? Okay, let me tell. So we use the weights for one reason, because when we run through the epochs, after finishing one epoch, we will get the output, a temporary output, and we will optimize it again. So that's the reason why my optimizer is defined. And after optimizing it, I will get fresh weights, and I will do the back propagation again. So for that reason, I set my weights. Initial weights was one thing, and that weight would get changed every time. So I have to set an initial weight. For that reason, I set the weights. And the same funda goes for anywhere else in deep learning. That's the reason I set the weight there. So my weight was 10 to the power minus 5. So I use that thing. So after this, after you obtain your accuracy and all, just print the labels, you are done with. Like that was your main aim, na, ki to obtain the labels of your test data set. So you are getting it. So that's how like this was a simple dog versus cat classifier, like in a complete project mode. Okay. So yeah, if you have any doubts, you can just ask. For today, the project discussion has just come to an end. Well, if you don't have any doubts, you may also leave the class.
So should we wait to see the this training of this epoch finishing of the epochs? It's taking a lot of time. Has it finished yet?
As you can see, like my GPU is still going on a red, so that means the training of the DenseNet has only not completed. Well, like I guess it would take another 15 to 20 minutes to run the entire thing. Like it took, basically what I did is that I kept this model training for like in the night, like before going on to sleep, I just trained the entire, I just ran on the cells, and when I just woke up in the next morning, I saw all my cells done. So I also don't know that exactly how many hours it will take for the entire dataset to get trained. So one thing
Okay,
is that,
so we should leave.
yeah, you may leave if you don't have any questions. So like, were you the only student who was asking with me about TPUs?
So I was the one. I was the only one. I was
Yeah.
not asking
So
you.
yeah,
Yeah.
so you can do one thing, that you can just try on it, that use the TPUs and see that if it just happens anything faster. Okay.
Okay, sir. I'll tell you about it tomorrow. It's okay.
Okay. Okay. And one thing to everyone else, that this out of RAM problem, like in this case, I used a very small amount of small amount of data to train. So for that reason, I was not able to, like my RAM basically was like enough for that reason, because my training part was also very small, the training data that I took. But if you have any other, like without decreasing your training data set, if you just if you can do without just making your RAM out of memory, just if you have any solution, then you can just DM me. Okay. Okay, so you can leave.
And sir, is there any class tomorrow?
Okay, so regarding the tomorrow class, so the previous class was on Eclat theorem, right? So when during the previous class, I had discussed with you all guys that about that Thompson sampling and UCB, because they were the only two topics left. Thompson sampling and UCB, they require like 4 to 5 basic, like prerequisite statistical concepts. Okay, like if you just like, and and to explain that, I would not go through the statistical concepts prerequisites. Okay, so so but still, I got the request from some of you that take the class. So I don't know what to do. So I'm just like taking an opinion from you all. So do you want to attend that UCB and Thompson sampling class? Because see, if I try to understand, if I try to uh, just teach you the statistical concepts, that 4 to 5 statistical concept, it would take me a week, and then only I will be able to go to the Thompson sampling and UCB. And if you are not going into basically that research purpose, that thing is also not required. So, any opinion from your side? I just want
Exactly
to know.
what, sir, exactly what statistical are you talking about? Can you name them? Like maybe we are already knowing that. Name them?
Um okay, so one thing that I will do is just I'll just send a particular list. Okay, because The exact names I don't remember now. I will just send you a list. These all things I require, prerequisites. I put in the WhatsApp group. Okay, so maybe you can see from there. Okay, so let me do one thing. Let me do one thing. I'm just taking the class on Thompson sampling and UCB tomorrow. Okay. Those who want to attend, just attend. Those who like know what that thing is, so they attend. And those who don't want to do it, no problem. Because like I need a multi-armed bandit problem concept. So that is the basic like thing that I required. Some concept of reinforcement learning I would require. Okay. Another thing is that of like uh, like there are many different kind of things. Okay, so this those who want to attend tomorrow's class, they can attend. Others cannot.
And so gangs and autoencoders is also left.
Yeah, GANs and autoencoders, I will just probably send you a project like that. Okay, I don't want to discuss the theory behind it because it's not theory oriented actually. Okay, so
And so there was one more thing, self-organizing maps. Is this a different topic or something?
no, self-organizing maps is a part of this UCB, like that thing.
Okay. And so Boltzmann machine is also or something.
Yeah, they all are the part of the same thing.
Okay.
Okay, so yeah, so that's what it is.